Guys, welcome to our channel, and today is our second lecture of the topic sequence and series. If you have not watched our first lecture, then go to our channel and please watch, and please like, share and subscribe our channel. So let's start. The first topic of today is the sum of AP, sum of arithmetic progression. Like there's a series A plus D, A plus 2D and so on, and we have to find the sum of its n term, and we can say that the n term will be A plus n minus 1 into D. So what will be the nth? What will be the sum of this series? This is the S n. Okay, if we add plus dot 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 plus. Okay, so we are going to derive it. So like we can write A is equal to an minus n minus 1 into D, because we know that that A plus n minus 1 into D is equal to a n. So we can write this. Okay, so we can write it like that, as n is equal to an minus n minus 1 into D plus an minus n minus 2 into D plus and so on, and the last two terms will be an minus D and an. So if we add equation number first and equation number second, then we will get 2 Sn is equal to n a plus an, n times a into n times an. So we can write this like Sn is equal to n by 2 and into a1 or a plus an, and we can also write it like n by 2 2a plus n minus 1 into D. So this is the your important formula of sum of arithmetic progression of n term. We will do some questions on this formula in the last of the lecture. So the next topic is arithmetic mean. What is the arithmetic mean? The arithmetic mean is the average of two terms. Like there's a three terms in AP: A, B, and C. Then the average of A and C, average of A and C will be B. How? Like B will be A plus C by 2. This will be B will be arithmetic mean of this AP. Okay, we know that A plus D is equal to B, and B plus D is equal to C. So we can say that B is equal to A plus C. From these equations we can say that then B will be A plus C by 2. You can prove it in this way also. So and the next thing is, if there are an arithmetic mean term in between two term of AP, like this is A and this is B, you can say so, and there's n arithmetic terms between these two terms, A3 and so on, A n. Okay, so what will be the A1, what will be the A2? So A1 will be A n plus B upon n plus 1, and A2 will be A n minus 1 plus 2B upon n plus 1 and so on, and the an term will be A plus and B upon n plus 1. So now we study the properties of arithmetic progression. There's a basic properties of it, so we just study some 2 or 3 properties. The first property is like if you are given in the question that the 5 terms or 3 terms or 2 terms are in AP, like is given that the 3 terms are in AP and their sum is 9. Then if you assume that the 3 terms are A plus D and A plus 2D is equal to 9, if you add them, then you can't solve this equation because you can't get the value of A and D from this equation. But if you assume that the terms are in AP is A minus D, A and A plus D, then you can sum of them, A minus D plus A plus A plus D is equal to 9. So from here D will be cancelled out and 3 is equal to 9, and A will become 3. So this is the approach of doing questions. The same thing if you have given that the 5 terms and 4 terms. So I will show you how can you do that. So first let me erase them. So let it be here. So If the 5 terms are given, then you can say so. The 5 terms will be a minus 2d, a minus d, a plus d, and a plus 2d. And if we talk about the 4 terms, the 4 terms series, the 4 terms will be a minus 3d, a minus d, a plus d, and a plus 2d. In this series, the common difference will be 2d. So this is the all we studied. And the another property of AP, like this is an AP, a plus d, a plus 2d, and so on. If you add or subtract any constant in this series, the new series you get will also be a arithmetic progression. Okay, so this was our arithmetic progression among the 4 series. So now let's move on to the another topic, another series, that is geometric progression. It's very important from exam point of view, especially from competition exams like JEE, JEE, NDA, AIEEE, and other engineering entrance examinations. So let's have a look. A geometric progression is a sequence in which any element after the first is obtained by multiplying the preceding element by a constant called the common ratio, which is denoted by R. Like there's any sequence, the first term of the sequence is A, and if you want to get the second term of the sequence, you have to multiply R, which is called the common ratio, in the first term, and then you have to multiply it again and again. For example, sequence 1, 2, 4, 8, 16, 32. The first term is 1. For getting second term, you have to add 2 in the first term, and for the getting next term, you have to multiply 2 again and again in the previous term. So then you will get a series. So this is the geometric progression, basic idea of GP. We also called it GP. GP. Okay. So before talking about the elementary properties of GP, we should discuss the scale factor of GP. Like this is a series A, AR square, AR cube, AR raised to the power 4, and so on, where A cannot be 0 and R cannot be 0. This is called a scale factor, because if A and R is 0 or any one of them is 0, then there is no sense of making this series. So A and R cannot be 0. Now we will study its elementary properties, that what is elementary properties of GPR. So first we will talk about the nth term of GP. So nth term of GP is given that Tn is equal to A into R raised to the power n minus 1. So this is the nth term of any GP. This is the if any, for example, in series like 1, 2, 4, 4, 8, 16, 32. So if you want to find the next term, 1, 2, 3, 4, 5, 6, there's 6 term in this series. If you want to find the 7th term in this series, so T7 will be A is 1, and R raised to the power R is 2, and minus 1. 7 minus 1 is 2 raised to the power 6. That is 64. So the next term will be 64, double of 32. Okay. Then the sum of first n terms of GP. Before that, we should know that geometric sequences also follow recursive relation. Recursive relation. It means that an is equal to r into an minus 1. This is called recursive relation of any geometric progression. Okay, and also that n belongs to I, and also that n is greater than or equal to, because n cannot be negative though. It does not make any sense that minus one term of any GP. Okay, so then the sum of first n terms of GP will be as n a into r s to the power n minus 1 upon r minus 1 if mod of r is greater than 1, and if mod of r is less than 1, then the sum will be this. Okay, s and the sum of first term a first term are common ratio, sum to infinity. Like we are taking this series into the n term. But if n tends to infinity, or there are infinity numbers of terms in this series, like we are 5, 10, 20, 40, 18, and so on, it is going to infinity. There's no limit to the terms, or n tends to infinity, we can say so. For this condition, then if we put infinity in these two equations, we will get that as n for r mod of r is greater than 1 is infinity, as infinity will be infinity for mod of r is greater than 1. Okay, so now let's move on to the another topic, that is geometric mean, like arithmetic mean. The geometric progression also have geometric mean. We say it GM, geometric mean. So if there are three terms in the GP, A and B and C, then the geometric mean of A and C will be B is equal to root AC, because we know that B is equal to AR, and so R is equal to B by A, and C is equal to BR, then R is equal to C by B. From here we can say that B by A is equal to C by B, then B square is equal to AC, and B is equal to under root AC. This is the geometric mean of this series. And if there is n geometric mean terms between A and B, two terms between A and B, then the G1, like A, the G1, G2, G3, dot 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 dot, and Gn, and there's B. So G1 will be A into B by A raised to the power 1 by n plus 1. This will be the G1, and G2 will be A B by A raised to the power 2 upon n plus 1, and so on. And the Gn will be A into B by A raised to the power n upon n plus 1. So this was the topic geometric mean. So thus you can find the geometric mean of any GP. So now we will study about the basic properties, basic properties of GP. Okay, so there's every basic property, there's no need to learn so much them, but there are some properties like if you are taking 3 terms in GP, you have to take 3 terms in GP, then 3 terms will be AR in inverse or A upon R and A and AR. If you are taking 4 terms, it would be AR minus 3, AR and AR square. And for 5 terms, this is the same as the arithmetic progressions term process, like we discussed before. So this would be AR raised to the power minus 2, AR raised to the power minus 1, AR and AR square. Okay, so this was the 3 basic properties like AP we have studied before. So now important another property that was not in AP, this was GP and that was not in AP, that is if there's n numbers in any GP like A1, A2, A3 ... and n numbers are in GP, and you have to find the nth term, rth term or kth term in this series from the end, not from this side. You have to find kth term from this side, from the opposite side, from the end, and this is from start, from the end. Then the kth term will be a n into 1 by r raised to the power k minus 1. So this will be your kth term from the opposite side, where the n is the last term and r is the common ratio. R is equal to common ratio. Okay, so last but not least property of GP is that if x1, x2, x3 and so on xn terms are in GP, then log x1, log x2, log x3 and so on terms will be in AP. So now we look at the proof of this, that because x1, x2, x3 and xn are in GP, then we can say that x2 square is equal to x1 x3. So if we take log of both sides, then we can say that log x2 square is equal to log x1 x3. Then 2 log x2 is equal to log x1 plus log x3. This equation is similar to the equation 2b is equal to a plus c. So we can say that log x1 log x2 and log x3 and so on are in AP. So this was the second last property, sorry, because I just remembered the another property, that is arithmetic mean is always greater than or equal to geometric mean. This is the most important property for your exam point of view. So because many of the questions were asked in many exams, so now we'll do some questions on that. So the first question is, the five numbers are in AP whose sum is 25 and product is 2520. If one of these five numbers is -1/2, then the greatest number among them is. So five numbers are given, so we know that what five numbers we have to assume is a minus 2d, a minus d, a plus d, and a plus 2d. Their sum is 25. So 5a will be 25 because each d term will be cancelled out. Then we can say that a is equal to 5. Okay, and the product is 2520. So their product 1a minus 2d, a minus d, a plus d, and a plus 2d is 2520. So a is 5, and from these terms we can say that a square minus 4d square into a square minus d square is equal to 2520. And then we will put the value of a, 25 minus 4d square, and 25 minus d square is equal to 540. Yeah. So sorry, this will not be 540, this will be 504. So then we multiply it inside. This will become 625 minus 25d square minus 100d square plus 4d raised to the power 4 is equal to 504. Okay, so if we solve this equation, we will get the two values of t. So let's solve them. So this is 4d raised to the power 4 minus 125d square, and this will become plus 121 is equal to 0. So now we factorize it. We can write it like 4d raised to the power 4 minus 4d square minus 121 plus d square plus 121 is equal to 0. Okay, so we can take 4d square common. This will become d square minus 1 minus 21 common, and this will become d square minus 1 is equal to 0. So 4d square minus 121 and d square minus 1 is equal to 0. These two numbers, these two factors are generated. So from here d will be plus minus 11/2 and d is equal to 1. D cannot be equal to 1 because you can see the question that one of these five number is -1/2. So this number cannot be so D cannot be 1. So D is plus minus 1/2, and it is given that one of these five number is -1/2. Then the greatest number amongst them will be what? So greatest number, if D is equal to plus 1/2, then the greatest number greatest number will be a plus 2d. A plus 2d is equal to 5 plus 2 into 11 by 2, that is 5 plus 11, that means 20, 16, sorry, 1 and 6. And if d is equal to minus 11 by 2, then the greatest number will be a minus, this will become 5 minus 2 into minus 11 by 2. So this will get same answer, 5 plus 11, that means 16. So option A is correct. Now let's move on to the another question. It is given that f r to r be such that for all x belongs to r, and these three terms are given. This first term, second term and third term are in AP. Then the minimum value of fx will be what? So three terms are given, that 2, 1 plus s x plus 2 raised to the power 1 minus x, okay, and fx and 3x plus 3 raised to the power minus x are in AP. Then we can say that fx is equal to 2 raised to the power 1 plus x plus 2 raised to the power 1 minus x upon 2 plus 3 raised to the power x plus 3 raised to the power minus x upon 2. So now we will use the property number 6, that is arithmetic mean is always greater than or equal to geometric mean. So because AM is always greater than or equal GM, then we can say that 2 1 plus x plus 2 1 minus x upon 2 is greater than or equal to the geometric mean of these terms, if these terms are in GP, and then the common ratio will be minus 2x, 2 raised to the power minus 2x. So we can say this geometric mean will be 1 plus x into 1 minus x. So this will become plus 2 raised to the power 1 minus x upon 2 is greater than or equal 4, it means 2. Upon 2 is greater than or equal to 2. We will use the same process for this term. We have used for this term, now we will use for this term. So 3 raised to the power x plus 3 raised to the power minus x upon 2 is always greater than or equal to 3 raised to the power x or 3 raised to the power minus x. This is plus, sorry, so this will become, well, 1. So from equation 1 and equation 2 we can say that fx is greater than or equal to 1 plus 2, that's mean 3. So the minimum value of fx will be 3. This would be the minimum value of fx. So this is our answer, and we have done our question. So this was our second lecture of our topic sequence and series. You can download notes of this class from the description box, and if you like this video, please like, share and subscribe our channel. Thank you.